Hey guys, so today I'm going to be talking about the Ferris wheel problem, and we're going to be answering these four questions. What is the velocity of the passenger cars on the Ferris wheel? What is the period of revolution of the Ferris wheel? What is the centripetal acceleration of the passenger cars? And what will the spring scale read at the bottom of the wheel? So one thing to note that's pretty important for circular motion is that all forces facing the inside of the circle are going to be positive. So gravity, for example, at the top of the Ferris wheel, that force is going to be positive, and at the bottom of the Ferris wheel, since it's facing outward, it's going to be negative. So to get started, you really only need these 2.5 sort of equations. The centripetal net force is going to be equal to your mass times centripetal acceleration, which is also equal to mass times velocity squared over the radius of the circle. And the other equation is velocity equals 2 pi times the radius over the period of revolution. And so the problem gives us a Ferris wheel that has a radius of 58.3 meters. A physics student enjoying the ride happens to have a sensitive spring scale and a mass of 300 grams hanging on it. At the top of the Ferris wheel, the spring scale reads 2.895 newtons. So I'm going to be writing all my answers in 4 significant figures. So to get started, we want to create a force equation for at the top of the Ferris wheel. And like I said before on the diagram, gravity, or our force of gravity, is facing inward, so it's going to be positive. And our normal force, which is the only other force acting in the situation, is facing outward, so that's going to be negative. So we can start by writing our force of gravity, which is positive, minus our normal force, is equal to our net centripetal force, but we can also write that as mv squared over r. So now we have our equation, and we can start substituting our force of gravity and normal force for what we know. Our force of gravity is always equal to mass times gravity, and in this case our normal force is going to be what the spring scale reads, so we can just keep that for now. And so we're going to solve for velocity, since that's what the first question asks for, and by doing that we're just going to rearrange the entire equation so that everything equals v. And if you were to do all the algebra, then you would get v equals the square root of r over m times force of gravity, or in this case mg, minus Fn. We can start to substitute in numbers now. So we're going to have r is equal to 58.3, since that's the radius of the Ferris wheel, over 0.3 kilograms, which is the mass of the weight on the scale, times 0.3 again, and gravity, which is 9.8, minus what our spring scale read at the top of the Ferris wheel, which we're going to substitute into our normal force, which is 2.895. And you're going to take the square root of all of that, and we're going to get 2.957 meters per second. That is the velocity of the passenger cars on the Ferris wheel. And the next question, We can box that. The next question reads, what is the period of revolution of the Ferris wheel? And this is where the other equation comes into play. All you have to do is first write it down and switch out the t and the v. And normally algebraically this would be multiplying t to the other side and dividing it again by v. And that will leave you with t equals 2 pi r over v. So here we already have the information we need. R is 58.3, which is the radius of the Ferris wheel. And v we just found, which is 2.957 meters per second. And if you were to calculate that out, that would come out to 123.9 seconds as your period. The next question asks for the centripetal acceleration of the passenger cars. And we're going to go back to the first equation for this question. So we're going to start with actually writing mass times centripetal acceleration is equal to mass times velocity squared over r. And right off the bat, these masses cancel out, so we're left with centripetal acceleration is equal to velocity squared over the radius. And substitute in your numbers. And that's going to come out to 0.1499 meters per second squared. And that is your centripetal acceleration. And the next question, final question reads, what will the spring scale read at the bottom of the wheel? And looking back at the diagram, our force equation is going to be a little different since we're at the bottom instead of the top. The only difference though is the signs of our forces will be flipped. So our force of gravity is going to be negative this time, while our normal force will be positive. And if we were to write that out, it would look like this. Normal force minus our force of gravity is equal to mass times velocity squared over the radius. And that's our force equation for the bottom of the wheel. And we're again going to find the normal force, since that's what the spring scale is reading. And all we have to do is move force of gravity to the other side, which we will be doing by adding. And again, our force of gravity is just equal to mass times the gravitational constant, which is 9.8. So if we were to substitute in our numbers, it would look like this. 0.3 times 2.957 squared over the radius, which is 58.3, plus what we have this time is force of gravity on the other side. We're going to add that. And after calculating that, it's going to come out to 2.985 newtons. Alright guys, that should give you a pretty good idea of how to do the Ferris wheel problem, and I hope this video helped.